Okay, I'm going to do a problem that's related to problem 27, very similar. I'm going to use the same formula that they have in the book. You might notice that I've kind of typed in the equation up here. I like that because I can see what I'm doing as I'm doing it. Okay, I've put the constants in already, so you don't have to watch me type that. But I'm going to look at these carefully. This is meters per second. This is joules. This is joules per degree Kelvin, and this is in micro meters. Okay, so this is going to be times 10 to the minus 6. That's one of the problems that a lot of people had. So one of the things I have to do is multiply this 1e minus 6 to get the constants correct. Otherwise, it's pretty much okay. Now, rather than try to do this all in one swoop, I'm going to actually try and do this a little bit at a time. So I'm going to start with this top piece of this, the bottom piece of this, and then the pieces of this. And I'm going to call these A1, A2, and A3. So A1 will equal 2 times pi times C squared times H. And that's all scalars. These are all scalar values, so I don't need any dots or anything in there. A2 will equal, I'm going to be careful here, lambda to the 5th. And I'm going to call it lambda 1, which is my thing there, dot. And I have to put the dot in there because it's an array of numbers. Okay? If I'm unsure, you can always run this as you're going, okay, without these things. It's not a bad idea to run it to make sure you're getting numbers that you expect. As you can see, I have these over here. So I'm going to go ahead and comment those out. A3, and that's going to be the last piece, which is down here. That's the most complicated. It's EXP, okay, of H times C, okay, those are both constants, dot slash, because now I got a lambda down at the bottom, and I better put that in parentheses, lambda 1 times, and these are both constants, so we'll be okay there, K times T, okay, and then I am going to subtract 1 from that. And so that gives me all my constants. I'm going to run that and see if I get, undefined variable T, T1, I'm sorry. T1 is what I named it. That's the temperature. Okay, so I've kind of checked all these. I put a semicolon here. Now I can calculate R. R equals, and that's going to be A1 divided by A2 times A3. Okay, and let's go ahead and let that spit some, I've got to have a dot there, or I'm going to be in trouble, and I'm going to have a dot here, once again, because notice it says inner matrix dimensions must agree. That's a thing that's telling me right away, hey, I've forgotten to put the dots in there, okay? Now that's looking a lot better, okay? And if I go back, if I pull this file over and look at the size, R and lambda should be exactly the same. Exactly the same size. 1 by 1,000. Perfect. Okay? Now I'm feeling pretty confident about all this. So plot. And I plot it. Okay, and you see my plot looks very much like one of the plots in the actual assignment. So the key to this really is breaking this down and then checking yourself at each step along the way by looking at the numbers, looking at the messages that Matlab sends you. I made some mistakes, but I was able to easily correct those mistakes because I looked at it at each step, corrected it before I went on to the next step. I hope this helps you out. You'll have to let me know.